Welcome to the Explainer. Today, we're going to talk about AWS Lambda, specifically all those core configuration options. We're going to cut through the dense documentation and turn it all into a super clear, practical guide so you can really master the settings that control your serverless apps. We're going to break this down into 4 key parts. First, we'll hit the fundamentals, just getting your code up and running in Lambda. Then we'll get into the fun stuff, tuning for speed and efficiency. After that, we'll talk about connecting your function to other resources. And finally, we'll wrap it all up with the best practices for managing and securing the whole thing. Okay, let's start at square one, the foundation. The very first decision you have to make when you're creating a Lambda function is how you're going to package and deploy your code. This choice, it really sets the stage for everything that follows. So right out of the gate, you've got this fundamental choice. On one hand, you've got the simple zip file. This is perfect for smaller functions, a quick API endpoint, a webhook processor. On the other hand, you can use a container image. This is for your more complex stuff, giving you the flexibility to use custom base images, package bigger dependencies, think data pipelines that need very specific libraries. And as the note on the slide says, this choice is permanent for that function, so you really have to think about what you need up front. It's a one-way street. And if you go the .zip route, getting started is, it's a piece of cake. From the AWS console, it's just a simple 4-step process. You hit create function, pop in some basic info like the name and runtime, pick your processor architecture, and boom, you're ready to drop in your code. It's all designed to be super fast and straightforward. Okay, so your code is deployed. Now for the really fun part, optimization. Lambda gives you these incredibly powerful levers to tune your function's performance. And honestly, understanding these is the key to building apps that are not just efficient, but also cost-effective. All right, the most important performance setting is memory. You can set it from a tiny 128 megs all the way up to over 10 gigs. But here's the secret sauce, the thing that a lot of people miss. You're not just allocating memory. As it says right there, more memory also means more CPU power is allocated to your function. So if your code is CPU bound, just cranking up the memory can make it run way, way faster. Next up is ephemeral storage. This is basically a temporary file system you get in the /tmp directory. So what if your function needs to do some heavy lifting, like downloading and processing huge files, decompressing archives, or loading up big machine learning models? Well, you can crank this temporary disk space all the way up to 10 gigabytes to handle all of that. Now, you really want to think of the timeout setting as your critical safety valve. It's the absolute maximum amount of time, anywhere from the default 3 seconds to a full 15 minutes, that your function is allowed to run for one invocation. Getting this right is so important for preventing functions from just running away and racking up unexpected costs, especially if you're calling some external API that might be slow. You also get to choose the processor architecture under the hood. The default is the familiar x86-64, but Lambda also supports ARM64, which runs on AWS's own custom Graviton 2 processors. And for a lot of workloads, this is a total game changer, often leading to way better price performance. And here's where you can really see that benefit. For tasks that are heavy on compute, I'm talking video encoding, scientific simulations, that kind of thing, functions running on Graviton 2 often give you better performance and they cost you less. That's a powerful combo that's definitely worth checking out for your apps. Now, in the real world, functions rarely live on an island, right? They almost always need to talk to other things like databases or caches. So let's dig into how you can securely connect your Lambda functions to resources that are running inside your own private network. The key to all of this is the Amazon Virtual Private Cloud, or VPC. The easiest way to think about it is like your own private walled-off section of the AWS cloud. It's the place where you can launch your resources, like a database, in a private network that you completely control. So here is the super important gotcha you need to remember. The moment you attach your function to a VPC so it can talk to your private resources, it loses its default connection to the public internet. This is a security feature, right? By default, it's totally locked down inside your private network. Which of course leads to the big question everybody asks. Okay, if my function is now inside my private VPC talking to my database, how in the world can it also call some third-party public API out on the internet? And the answer is a NAT gateway. It's kind of like a bouncer for your VPC. You put the NAT gateway in a public subnet, and then you tell your private subnets to route all their internet-bound traffic through it. This creates a secure one-way door. It lets your private functions reach out to the internet, but it doesn't let the internet initiate connections back in. Actually hooking this all up in the console is really simple. You just edit the function's VPC settings, pick the VPC you want to connect to, and then choose the right private subnets and security groups to control its network access. Okay, let's bring it all home with our final section, control. We're going to cover how to manage your function's configuration on the fly, and, maybe most importantly, how to keep your sensitive information secure. Environment variables. Man, these are so incredibly useful. They're just simple key-value pairs that you pass into your function's configuration. This means you can change how your function behaves, like pointing it to a different S3 bucket, without ever having to redeploy your code. They are absolutely perfect for non-sensitive settings. But, and this is mission critical, you should never, ever put secrets in environment variables. And look, it's not just me saying this. The AWS documentation is crystal clear about it. For stuff like database passwords, API keys, or any other kind of secret, you should always use a dedicated service like AWS Secrets Manager to keep them safe. So by default, Lambda encrypts your code and environment variables for you, which is great. But what if you want total control? Well, for an extra layer of security, you can bring your own customer-managed key from the AWS Key Management Service, or KMS. When you use your own key, one that you create and manage, you have full control over its entire lifecycle and who's allowed to use it. And setting this up is pretty straightforward. You go into your function's advanced settings, you enable encryption, and you just select the key you want to use. The final crucial step, and this is the one people sometimes forget, is you have to update your function's execution role to give it permission to actually use that key for encryption and decryption. And there you have it. We've gone from deploying and tuning to connecting and securing your AWS Lambda functions. You now have the foundational knowledge, the keys to the kingdom really, to configure functions that are powerful, efficient, and secure. So the only real question left is, what are you going to build next?